Alright, so we're looking today at section 3.5 where we're specifically going to look at what are the derivatives of trig functions. Now, first things first, let's consider the function y equals sine theta. So if we're talking about sine theta and our x-coordinate system, our x-axis here is the theta and y is the y value. But we're looking at what is the slope for various values of theta. So for instance, if we were to make a graph of the slope, just at certain points, pick some out, figure out approximately what the slope is, and then plot those points, those values on the y value in place of that, what would we come up with? Well, let's see. So for a given theta, let's say theta is negative pi. What does the slope look like right there? Well, it looks like the slope is going down about as fast as it's going to the side. So we've got a slope there of negative 1. When we get down here, so we plot the point at negative pi of negative 1. Then when we get over here to roughly about negative pi over 2, 1.57, we see here we've got a slope that's going to be 0. If we were to draw a tangent line in there, at that point it would have a slope of 0. So that means we plot at that point a point of 0. Move on over and go to 0. So the sine of 0 right here, this thing is going to have a slope that looks roughly to be positive 1. So at the point 0, we're going to plot the point 1. And all we're doing with these points right here are plotting what the slopes are at those points along this graph right here. That's all we're doing. So we're just figuring out what approximately the slope is for the blue line here, and we're plotting a point at that value for that given theta value. So let's go on over here to pi over 2, 1.57 here, and we're looking at this point right here. And what's the slope look like right there? Well, the slope looks like, once again, you got a horizontal tangent, so the slope is going to be 0. So we're going to plot a point at 0, at pi over 2, 0. And then when we get over here to pi, 3.1415926, we look at that point and we see that we've got a slope that looks like it's negative, and it looks very similar to this one right here, so it's going to be negative 1. So then we plot a point down here at negative 1. Now if we come in here and graph these together with a nice smooth curve, what do we have? Well, if we connect those dots, we have something that hopefully you recognize. That is the cosine function. The resulting curve that we get is a cosine curve. So according to that, the derivative with respect to x of sine x is cosine x. So that's literally how you could figure it out. There are other ways to derive it, but that's a way you could figure it out. All right, let's do the same thing, but we're going to do the same thing for cosine this time. So if we do cosine, we start off with that graph. We're going to go a little quicker through this. We're going to do the exact same points, negative pi over 2, 0, pi over 2, and positive pi. So when we do that, we've got a slope of 0 there, so we're going to plot 0. And here we've got a slope of 1, so we're going to plot the value 1. And then at 0 we have a slope of 0, so we're going to plot that value at 0. And then at pi over 2, we're going to have a slope that's negative 1. So we plot a point down here at negative 1. And then over here at pi, we have a slope of 0 again. So we plot a point right there. Remember, our points here are signifying what the slope is of the blue line at those given theta values. All right, so when we connect these, we're going to get a graph that, well, if we look at it, that's not sine. What is it, though? Well, it kind of looks like sine, but it kind of looks like sine is shifted, or it's flipped over. If you remember, sine would start at 0 and it would go up and come back down and go through the cycle. And over here it would go down and come back up. So all that's happened here is this thing has flipped across the x-axis. Well, what's going to flip all your y values across the x-axis to the other side of the x-axis? Well, that's just throwing a negative in front of it. So the resulting curve is a sine curve that's been reflected about the x-axis, so the derivative of cosine x is just negative sine x. All right, so looking and knowing those two things, we can actually work on finding the derivative of tangent by using the quotient rule. So if we have the derivative with respect to x of tangent x, we can think about that as sine x over cosine x, and if we take the derivative of that, remember it's going to be bottom cosine x times the derivative of the top. Derivative of sine x is cosine x, minus top sine x times the derivative of the bottom, which is going to be negative sine x, all over the bottom squared. So cosine x quantity squared. Now, when we simplify on the top here, cosine x times cosine x gives us cosine squared x. And then this negative times this positive, or you can think of this as a negative sine x times a negative sine x, gives us a plus sine squared x over cosine squared x. When we square the cosine, we get cosine squared x. Now, if you go in here, there's a couple of ways you can think about this. You can actually go in and you can divide that into both parts. But the best way to do this is to recognize what you have right here. Remember, there's a Pythagorean identity that says sine squared x plus cosine squared x equals 1. And if you remember, that actually comes from the equation for a circle, specifically the unit circle. Sine squared is y, cosine squared is x, x squared plus y squared equals 1. So this up here on top is actually equal to 1. So we end up with 1 over cosine squared x, or cosine x squared. And what is 1 over cosine? Well, 1 over cosine is secant, and since we've squared it, it's actually going to be secant squared x. So you've just derived what the derivative is. You solved algebraically and found what the derivative was for tangent. So the derivative of tangent x is secant squared x. So the derivative with respect to x of tangent x is secant squared x. Now, we could go through and we could derive every single one of these using quotient rules or things like that. We're not going to do that. What we're going to do is we're just going to look at them and know what they are. So the derivative with respect to x of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. Now, one of the ways that you can remember all the co things over here are going to have cos that are their derivatives. That's one of the things that I remember. Cotangent has a derivative that is negative cosecant squared. Cosecant is cosecant cotangent, co. And don't forget your negatives in front of the ones that start with a C. You can see everything that starts with a C has a negative in front of it. So that's another little memory tool for you to remember. All right, that's it. Make sure that you start memorizing and knowing all those trig functions and their derivatives backwards and forwards and sideways. You've got to know these. You've got to be able to recall them off the top of your head with no real thought needed. So make sure you start memorizing those.